Hi guys, this is Dr. MK and welcome to Ultimate Organic Chemistry. In the previous video, I discussed aldol condensation and its types. In this video, I am going to discuss intramolecular aldol condensation reaction. What do you mean by inter and intramolecular aldol condensation reactions? For example, if you happen to see this reaction, the two molecules having aldehyde or ketone functional group, they react together in the presence of acid or base catalyst to form this type of compound, which is known as intermolecular aldol condensation reaction. What do you mean by intramolecular aldol condensation? For example, in this molecule having two functional group, that is aldehyde or ketone, which are present in the same molecule itself. Okay, so when they react in the presence of acid or base catalyst, it will form a cyclic compound, which is known as intramolecular aldol condensation reaction. So inter means between the molecule and intra means within the molecule. So this is about the difference between these two reactions. Okay, so this reaction is going to be very important to IIT JEE, IIT JAM, or TRB or GATE or CSIR or this type of exam who are studying, though this reaction going to be very important. Okay, so please do watch, because I have categorized this intramolecular aldol condensation reaction into 5 different types. Okay, so along with that, I am going to discuss 2 different questions from AIIMS and CSIR examinations also. Okay, shall we start? Fine, let us take this example in which adipaldehyde is reacting with base in water as a solvent. It will be converted into cyclopent 1-ene carbaldehyde as a product. Okay, so before going to the mechanism of this reaction, I would like to discuss the symmetry of this molecule. Suppose if I cut the compound between these two carbon atoms, so number of carbon atom in this side and this side both are same. That means the compound is symmetrical in nature. If a compound is symmetrical in nature means this alpha hydrogen and this alpha hydrogen both are same. Okay, so the base, what happens, it abstracts this hydrogen and this bond is broken. This electron will move towards the carbon atom. As a result, it will generate a carbanion. When this carbanion is undergoing resonance with the carbonyl compound, okay, because this is the electron withdrawing group, so this electron will be moving towards the carbon atom and this electron will move towards oxygen atom. As a result, it will form an enolate, so which I have discussed in the previous video in detail. If you want to see that, just go and watch, because I have given the link in the description section. Okay, right, so now what happens, this anion comes back here and it has to attack this carbonyl carbon. As I said, here you have del plus and here you have del minus. Once it is attacking, this electron will move towards oxygen atom. As a result, it will lead to the formation of a 5-member ring. For example, this carbon atom and this carbon atom are connected together. So if you give numbering here 1, 2, 3, 4, 5, so it will lead to the formation of a 5-member ring. So as a result, you will get this type of intermediate. Okay, so as usual, I am giving number here. So let me start here, 1, 2, 3, 4, 5. So first carbon you have this functional group. Okay, so this is after reaction becomes C double bond O. As a result, you have here C double bond O, and 2, 3, 4 you do not have any other substituents. Okay, at the 5th position you have C double bond O becomes C single bond O minus. Okay, so it has become C single bond O minus, and here you have hydrogen. It is not necessary to mention, right? So once this alkoxide is formed, it reacts with the water molecule by abstracting the proton. As a result, this OH will be leaving as OH minus to form the corresponding alcohol, right? So now this OH, this base medium, it is reacting with this hydrogen atom, which is alpha to that carbonyl group, and which is acidic also. Once it is abstracting the proton, the electron moves towards the carbon atom. As a result, it generates a carbanion. Okay, so once this carbanion is generated, it moves towards the carbon and it pushes the oxygen atom, and the oxygen atom is leaving as OH minus, it provides a corresponding product. So this is about the mechanism of intramolecular aldol condensation. Okay, so now let us see the 5 cases that I have mentioned in the introduction. Okay, so the 5 cases I am going to discuss here, which are very important. Please listen carefully. Okay, so the first case is if you have both side ketone, right, and you have 2 sets of alpha hydrogen, for example, and if you check the symmetry of the molecule, it is symmetrical only. Okay, so either side you have same number of carbon atoms, so it is symmetrical. Oh, let me focus on this C double bond O system. So it has 2 different type of alpha hydrogen. The one is here, that is methyl, the other one is here. So there are 2 different type of alpha hydrogens here. Okay, so when a ketone is reacting with the acid, so it will form keto-enol tautomerization. Okay, suppose if there are 2 possibilities that I have said so far. So one is this alpha hydrogen is undergoing tautomerism, means you will get this type of enol, and the other possibility is if this alpha hydrogen undergoing enolization, it will lead to the formation of this enol. Okay, so there are, you have 2 different set of enols. Okay, both will be there in equilibrium, please remember. Okay, so now the next step is this electron comes back and this carbon attacks this carbonyl carbon, and this electron moves towards the oxygen atom and it will be protonated, and this hydrogen whichever is leaving will be added to this oxygen atom, please remember. So as a result of this, it will lead to the formation of 1, 2, 3, 4, 5, 6, 7, 8. It will lead to the formation of an 8-member ring. Okay, so you will get this as a intermediate. Okay, so for example, I give the same numbering here. So here you have CS2, I have given 1, 2, 3, 4, 5, 6, 7, 8. So between 1 and 8 a bond is formed, which I have mentioned in red color. Okay, so after this addition, the C double bond O becomes C single bond O minus, and this hydrogen will be protonated, and in the case of the second carbon, this OH will be converted into C double bond O. This is about the first step. Okay, so suppose if this enolate is reacting here, so what will form? For example, this electron comes here and this carbon atom attacks this C double bond O carbon, and this electron will move towards oxygen atom. As a result, this hydrogen will be going there and it will be protonated. So this is the simplest way I am explaining you. Okay, so as a result, in this case, it will form 1, 2, 3, 4, 5, 6. It will lead to the formation of a 6-member ring. Okay, so first this as a carbon, 1, 2, 3, 4, 5, 6. Okay, at the first position you have a ketone functional group, because after reaction this will become double bond and you have a ketone functional group here. Okay, and in the case of 2, 3, 4, 5 there are no substituents, and in the case of 6th carbon, the C double bond O becomes C single bond O minus. After protonation it will be converted into OH, and you have another substituent, that is methyl. Okay, so you have 2 sets of product. One is 8-member ring, another one is 6-member ring. So which will be preferred in this case? Okay, so when you have this type of things, you have that 6-member ring formation will be more facile. That 8-member ring formation will not be possible. Okay, because of ring strains. Okay, so for example, in intramolecular aldol condensation, you can remember like this. The formation of 5-member and 6-member are very easy ring, and the formation of 3, 4, 7, 8, which are very difficult, you can say it is very tough. Okay, so it is some cases it is not at all possible actually. Okay, so you can say that this product will not form and this product will form. Okay, so once it is forming means it will immediately undergo the elimination of water molecule in the presence of acid medium, and it forms this as a product. Okay, so now you can check this with this answer, that is the correct way. Okay, so please remember, when you have higher and lower membering, that 7 membering and 8 membering or 3 member and 4 membering will not be possible in the case of intramolecular aldol condensation, whereas the 5 membering and 6 membering formation will be more facile. Please remember. Okay, this is about the case 1. Let us go to the second case, where you have both side methyl ketone. So here you have methyl ketone, here you have methyl ketone, right? But in this methyl ketone, the alpha position is disubstituted, methyl disubstituted. Okay, so instead of this hydrogen atom, you have 2 methyl groups which are substituted. So what are the possible way one can generate the anion? First you need to check. So here you can generate anion because this is alpha position. Here you do not have alpha hydrogen, so you cannot generate, and here you have alpha hydrogen and you can generate anion here, and this side you have alpha hydrogen, you can generate anion here also. As I said already, if anion is generated, it has to attack here, it will lead to the formation of a 3 member ring, which is not at all possible. Okay, so you no need to consider about this hydrogen atom, you just focus on these 2 hydrogen atoms only. Okay, so in the first case, so the anion is forming at the right hand side. Okay, so this side the anion is formed, right? So once this anion is formed, will be undergoing delocalization. So after the delocalization, what will be the case? Okay, so and here you can form another type of anion, that is at the left hand side, and this anion will be formed, and this will be undergoing delocalization, and after that what will be the case, that we are going to discuss, right? So in this case, after delocalization it will form the corresponding enolate, and this case after that delocalization it will form the corresponding enolate, right? So when this electron comes here, it will attack this hydrogen and this carbonyl carbon, and this electron comes back and it will attack the carbonyl carbon. Okay, so in this case, what are the ring will be formed, that we are going to discuss. 1 2 3 4 5. So here you have 5 member ring formation, and here you have 1 2 3 4 5. Here you have 5 member ring formation. Both sides you have same 5 member ring formation. At this condition, what you need to do, that we are going to discuss. For example, in this case, that enolate attacks this carbonyl carbon. This carbonyl carbon is getting attacked by this carbon, which is sterically hindered. Okay, so why it is sterically hindered? Because of the presence of these 2 alpha methyl groups, so which are bulky in nature, which hindered the attack of this CS2 minus. So this type of attack will not take place. Whereas if you happen to check the other case, where you have only hydrogen atom at the alpha position, so the attack will take place very easily, and it will lead to the formation of the 5 member ring. So in this case, you will get the 5 member ring. You just draw a 5 member ring, right? So and you just give numbering like 1 2 3 4 5. Okay, at the first position you have CH2, so you no need to do anything, and the second position you have C single bond O becomes C double bond O, and third position you have dimethyl functional group, and fourth position, fifth position you do not have anything, and the fifth position you have a methyl group, and you have O minus. So because this double bond O after attacks, it becomes O minus. Okay, so which is getting protonated by water molecule. You have OH here you have CH3. Okay, so after the elimination of water molecule, so it will lead to the formation of this as a product. Okay, so this is about the second case. So we will go to the third case, where you have ketone versus aldehyde. So which side the reaction will take place? Okay, so you treat with the base KOH, and you have 2 sets of alpha hydrogen. One is here, another one is here. So you may think that this is also alpha hydrogen, but as I said already, it will lead to the formation of higher member ring. For example, this will attack here, means you will get 1, 2, 3, 4, 5, 6, 7. So you will get a 7 member ring. So you should not think about this alpha hydrogen. You need to focus only on these 2 alpha hydrogens alone. Okay. So what happens once this hydrogen is deprotonated? So it will form this anion. Okay. So this will be undergoing resonance. So it will form this enolate. Okay. So there is another possibility that this hydrogen is deprotonated, means you will get anion here, and if it is undergoing delocalization, means you will get this enolate, right? So you can answer this question in 2 ways, so that I am going to discuss. For example, in this case, this minus charge will come here, and this carbon atom attacks this aldehyde, and the electron will be shifting towards the oxygen atom. Right. So in this case, the electron comes here, and this carbon attacks this keto functional group. Okay. So in this case, the formation of 1, 2, 3, 4, 5, and here also you will get the formation of 1, 2, 3, 4, 5. So both sides you will get 5 member ring. So which is more facile, that we are going to discuss. Before that, you need to know one thing, the reactivity of aldehyde and ketone. Right. So if you compare these 2 things, aldehyde will be more reactive than ketone because of 2 factors. One is steric factor. So if you happen to check aldehyde, you have only 1 R group, whereas here you have 2 R group. That means it is bulkier groups, and it hinders the attack of the nucleophile. Okay. So the ketone is more reactive due to less steric hindrance. And the second reason is, this is electron donating group. Here you have 1 electron donating, because alkyl groups are considered to be plus I group, that means electron donors. Right. So once it is donating the electron through the sigma bond, that is plus I effect, so the partial positive nature of the carbonyl carbon will be slightly reduced. Okay. But in the case of ketone, you have 2 electron donating groups, and in comparison with aldehyde, the partial positive charge will be it will be reduced. Okay. So in the case of that donating ability, if you happen to check, aldehyde is more reactive because of more electrophilic C double bond O. Okay. Where here you have less electrophilic C double bond O, right? So if you compare this, if you apply this concept here, so what will happen here? The aldehyde is getting reacted in this case. Here you have ketone getting reacted. So as I said, which will be more reactive? Aldehyde will be more reactive, and this will be forming, and this type of attack will not be forming. Please remember. Okay. So this is about the first way. So what about the other way? If you check this enolate, and you have here you have double bond, and here you just mark this double bond, and you have 2 alkyl substituents, and here you just mark these 2 alkene double bonds. Here you have only 1 alkyl substituent. Okay. So here this is more substituted alkene, enolate you can say. So this is less substituted enolate. Right. So you need to do the reaction under heat condition. So heat condition favors that the thermodynamic product, which is more substituted enolate, will be the major one. So this is thermodynamic product. So under this condition, this will not form, and only this will be forming. Okay. So it will lead to the formation of a 5-member ring. You just draw a 5-member ring, and as usual you try to give the numbering 1, 2, 3, 4, 5, and the first position you have this functional group, that is C double bond O, CH3, and the 5th position you have O minus. Okay. So after protonation with water, it will form OH, and after elimination of water will lead to the formation of this product. Okay, so this is about case 3. Let us go to the case 4, where you have two sets of ketone. Here you have methyl ketone, here you have ethyl ketone, right? So both are not same, right? So in this case, as usual, you will get two sets of unolate formation. First thing is, if this hydrogen is deprotonated, it will form anion here, and it will undergoing resonance, it will lead to the formation of this enolate, right? So the next case is, if this hydrogen anion will be forming here after the removal of this hydrogen, and this will be undergoing resonance to form this enolate. Okay, so as usual, you just have to compare these two enolates. So here you have monosubstituted enolate, here you have disubstituted enolate. As I said already that under heat condition, thermodynamic product will be predominant, so this enolate will be formed major. So what happens is, electron comes back here, it will attack this carbonyl carbon, the electron will move towards oxygen atom, right? As a result, it will lead to the formation of 1, 2, 3, 4, 5, 6 member ring formation. So you need to draw a 6-member ring. As usual, you have to give the numbering from here, 1, 2. You can give from any places. It is not mandatory that you need to give only from this one. This is for our understanding only, because this is not perfect IUPAC nomenclature that I am teaching here. Okay, so we are here to solve a problem. For that purpose, you can give numbering wherever you want. Okay, so you can even start from here, and you just follow whatever the other numbering is coming. Okay, so this is 1, this is 2, 3, 4, 5, 6. Okay, the first position you have methyl substituent, you just draw that, and here in the second position you have C double bond O, and 3, 4, 5 you do not have any substituents, and the sixth position you have 1 methyl here and 1 O minus here. So after reacting with water, which will lead to the formation of OH, the final step is, that is condensation. Upon heating, it will lose water molecule to form this as a product. Okay, so this is about the case 4. The last case, that is 5th case, where you have two carbonyl compound in a cyclic molecule. So if you happen to check the 4 cases, they are like acyclic compounds. Okay, but in this case it is a cyclic compound, right? So here you have a cyclic ketone. First we need to check whether they are symmetry or not. Okay, so for example, if you check the number of carbon between these two centers, so 1, 2, 3, 4. Okay, so if you check this side, you have 1, 2, 3, 4. So both sides you have 4 carbon, but that means it is a symmetrical system, right? So let me focus only on this carbonyl compound. Okay, so you have one alpha hydrogen here, another alpha hydrogen here, right? So if this alpha hydrogen is reacting here, it will lead to the formation of a bicyclic ring, where you have a 5-member ring, because there is a bond formation between these two. So here you have 5-member ring, that is 1, 2, 3, 4, 5-member ring. Suppose the other side is check 1, 2, 3, 4, 5, 6, 7. So you will get 5-member ring and 7-member ring formation of bicyclic system. Suppose this hydrogen attacks this carbon, so you will have 1, 2, 3, 4, 5, you will get a 5-member ring. The other side you have 1, 2, 3, 4, 5, 6, 7, you will get a 7-member. So both sides you will get same 5-member as well as 7-member ring. That means these two hydrogen atoms are equal in nature. Okay, that is a conclusion. So this is equal, this alpha hydrogen and this alpha hydrogen, both are equal in environment, right? So let me explain the mechanism. So what happens when it reacts with hydrogen plus, that is proton, it is getting protonated because of this presence of lone pair of oxygen, and it will be protonated. As a result, you have alpha hydrogen here, so this will be undergoing tautomerism to form enol formation by losing a proton. Okay, so this is enol. So what happens next? This electron comes back here, and this will attack this carbonyl carbon, and this electron will be moving, and as a result this hydrogen whatever left will be protonated here. This is the simplest way I am teaching. Okay, so you will have a bond formation between this carbon center and this carbon center, and if you happen to check this ring, I said already this is a 5-member ring, this is a 7-member ring, and as a result it will be like this if you write in a proper way. Okay, right. Next thing is this will be protonated under acid medium, right? So it will form this hydronium ion, so which will be a very good leaving group. So once it is leaving means, and as a result this hydrogen will be coming. Once it is leaving, a carbocation will be generated. As a result the acid will be it will be regenerated as H plus, and you will get this is H3O plus, that will be leaving, right? I will get the final product. Okay, so in this case you will get this as a final product. So this is about the 1 to 5 cases. Okay, now let us discuss the question section. Okay, so we have a question here that is asked in AIIMS 2018. So a big molecule has been given, and it is treated with the dibal H followed by potassium hydroxide. I feel it is one of the toughest question actually. I feel that a +2 qualified student, I do not know how he will be able to solve this problem. I feel a little bit difficult here. Okay, so but we'll try to solve this. Okay, so what happens when an ester is reacting with dibal, which is a very good hydrate donor, which will selectively react ester, and it will be removed as O minus methoxy, and it will lead to the formation of aldehyde. So ester will be converted into aldehyde. So that you need to know. Okay, let us go to that explanation process. So here you have ester here you have ester here. You have 2 esters. When they are reacting with the dibal, so both esters will be converted into the corresponding aldehyde. So you will get the corresponding aldehyde. Dialdehyde will be formed, right? So once this dialdehyde is formed, it reacts with the potassium hydroxide. But if you check the answer, the mechanism could be as follows. Okay, so K plus OH minus will be generated, and this will be deprotonated. It will be forming the corresponding carbanion, and this carbanion can attack here or here. Okay, so if it is attacking here, it will lead to the formation of 1, 2, 3, 4, 5, 6, 7 member ring, so which is not possible. But if it attacks here, so it will lead to the formation of 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. It will lead to the formation of a 6-member ring. Okay, so this will be easily taking place, and this will not take place. Okay, please remember. Right. So once it is forming, I am giving the number here 1, 2, 3, 4, 5, 6 member ring formation, and here I am giving number 1, 2, 3, 4, 5, 6. Okay, the first position you have CH2, and the second position you have C double bond O, and third position you have CH2, and fourth position you have CH2, fifth position you have CH, and you have this group that I have mentioned here. Okay, so this is how the 6-member ring formation is taking place. Okay, so if you want to write the line structure, I'm just redrawing it. Okay, I'm just removing this CH2 and just putting a line. This is line structure. It forms a corresponding alkoxide. When this alkoxide is reacting with water molecule, it abstracts the proton and leaves as OH minus, and it will be protonated. Okay, the final step will be the removal of water will take place in the presence of base. So it will lead to the formation of this product. So the right answer would be option A, please remember. Okay, so we'll go to the final one, which is the advanced level. I believe this is also advanced level only, and I'll go to the other one, which is CSIR 2017 December. Okay, so you are given a molecule like this, and it is treated with potassium hydroxide and methanol as a solvent. So you have 4 options where you have 2 8-member ring and 2 6-member ring product formation. Okay, first you need to identify what are the possible alpha hydrogen that we need to remove. 1, 2, 3. So there are 3 alpha hydrogens can be removed. Okay, right. Now let us discuss, once this alpha hydrogen is removed, it forms this anion, and if it attacks here, it will lead to the formation of 1, 2, 3, 4, 5, 6, 7, 8. It will lead to the formation of a 8-member ring. Okay, we have the other possibility, that is this alpha hydrogen is getting attacking this carbonyl carbon, means it will lead to the formation of 1, 2, 3, 4, 5, 6, 7, 8. Again you will get the formation of 8-member ring. Okay, so the other case, that is third one, once this anion is formed, it will attack here and it will lead to the formation of, we will get a 6-member ring. So as I said in the initial stage of the video, that when you have 6-member, 8-member, always you have to give preference to 6-member ring, and these two things will not form. Okay, so in this case, please do not forget that you have here a bulky methyl group, and you have to think about the alternate way. Please do not think that because that is secondary. Once the first thing is the formation of ring size, that is what very important. Okay, so once it is forming, then that steric hindrance will not be a problem. Okay, right. So now let me solve this. So it will lead to the formation of a 6-member ring. Okay, so you need to give numbering here, 1, 2, 3, 4, 5, 6. So first carbon you have C double bond O, CH3. Second carbon you do not have anything. Third one you do not have anything. Fourth one you do not have anything. And fifth one you have dimethyl substituted. Okay, and the sixth carbon you have O minus and CH3. Okay, so once it is getting protonated in water medium, I'm sorry, here you have methanol. Okay, please remember. Right. Finally, it will lead to the formation of the double bond by eliminating the water molecule. So if I check the final answer, it will be like this. Okay, you just check with the options, that is you have methyl here, and next to that the dimethyl substituted thing is there. Okay, so you don't get confused with these two. So the right answer is option C. Okay, so that's all. So guys, hope you understood the concept discussed in this video. I believe it will be very useful to you when you write any sort of competitive examination. If you feel it is useful, you just give a like and you share with your friends, and please do not forget to subscribe the channel. And I will meet you all people with an interesting topic. Until then, take care. Bye.